Okay, guys, it's Kennedy at it again. So today we'll be looking at the hybridization of carbon in ethene. Now, this is ethene. Ethene is C2H4. So this is the structure C2H4. Okay, this is ethene. Now let me tell you what happens here. Now, before carbon forms this bond, carbon will form a hybrid orbital, which we call sp2 hybrid orbital. Okay, now see what actually happens. This is the orbital representation of carbon in an unhybridized state. Now this is 1s2, this is 1s2, this is 2x2, 2s2, and this is 2p2. Okay, now this is carbon in an unhybridized state. Now see what happens now. Before carbon forms this sp2, you see this one electron here will be promoted to this. Remember, this is 2px, this is 2py, and this is what 2pz orbital. Okay, very good. So one electron will be promoted here, but after the promotion, see the promotion here. It has been promoted. It will look like this. Then after the promotion, do you know what will happen? After the promotion, carbon will now form only sp2. That is, the orbitals that will be used will be this s orbital, this one, and two of this orbital. That is, this is 2px and 2py orbital. So that's what leads to sp2. Okay, yes, that's what leads to sp2. So now, each of these carbon has this sp2. Each carbon atom, yes, it has this sp2. Look at them here. Yes, they have it. Okay, remember, this is the structure of ethene. Then let's explain the second bond. Good. Then after forming this sp2 hybrid orbital, the bond form. So the other bond, see what happens. You remember that electron is being promoted to this 2pz orbital. Good. Now, this is a p orbital. This is p orbital. This is y. This is x, and this is what? Z. This is py orbital. This is px orbital. And this is pz orbital. Now, when you watch pz orbital, you find out that it is what? Along this axis, okay, which is 90 degrees to these other ones. Okay, you see that these other ones lies in 2 dimensions. That is, in 2-dimensional plane. Yes. So now, what I will do now is I will draw only this pz orbital. Now, this is the pz orbital of one of the, that is pz orbital of one carbon. This is another pz orbital of another carbon. This is another pz orbital of another carbon. Okay, another pz orbital. This is the axis pz. Now, because this orbital, they are the remaining orbitals. See what will happen. They will now come together. That is the 2 charged clouds. These are electron cloud. They will now come together, forming a collateral covalent bond. Okay, or we can call it collateral overlapping of electron cloud. Now, when they come together, they will bond like this. They will bond like this. See the bond here. They will bond like this. above and below the plane. That is, look at it. You see this shaded area? This is where they overlapped. So you see that the electrons that are being overlapped in this bond is less than the electrons that are being overlapped in this bond. Remember, this thing you see now is like this. The bond is like this. It's like this. Okay, you see. So this orbital, the electron cloud here is bigger than the electron cloud here. Remember, this bond is a sigma bond. Sigma bond is a collinear overlapping of electron clouds. Okay, that is when the orbital of this one overlaps the orbital of this one. That is along the axis of the hybrid orbital. Okay, that is overlapping along their axis. Okay, yes. So now remember, bonds are formed when there is maximum overlapping. Do you understand? So that is it. Now, because all these atoms, they lie on the same plane. Okay. Now, these two unhybridized orbital, they can come together because they lie on the same plane. That is when they will come together, the two unhybridized orbital. Yes, forming above and below the plane. One pz orbital from this one and one pz orbital from this one coming together, forming a pi bond. Okay, a pi bond. Yes. So this bond is a weak bond. So see that pi bond here. Good. It's a weak bond. Okay, good. Now, because this carbon forms one sigma bond and one pi bond, it makes this ethene C2H4 to be a reactive what? A molecule or a reactive substance. Okay, because of this weak pi bond here. Do you understand? So this is it. So this is how the hybridization of carbon in ethene. I hope you understand it. Okay. So the shape is a trigonal planar. Okay, this is the shape. Trigonal planar. Okay, that is along the two-dimensional plane. Do you understand? This is the shape of the orbital along the two-dimensional plane, trigonal planar. Don't worry, later this topic will lead us to shapes of orbitals. Okay, so this is what actually happens. Okay, so hydrogen will be here, hydrogen will be here, hydrogen will be here, hydrogen will be here. So in my next video, I will come for the bonding, the hybridization of carbon in ethene. See you guys in my next video.